You ever stop to think about that hidden world running right under our feet? That massive network of pipes that keeps our cities going, powers our biggest industries, and even helps grow our food? Well, today, we're going to pull back the curtain on a material that's completely changing the game down there: GRP pipes. Let's get into what makes this stuff so special. Just let that sink in for a second. 100 years with zero maintenance. I mean, that sounds like a crazy claim, right? But that's the promise we're talking about here. And as you're about to see, it's not just talk. It's actually reshaping how we build our world, from the ground up.
Okay, so what is this stuff anyway? GRP. The simplest way to think about it is like steel rebar inside of concrete, but we're talking on a microscopic level. You take these super strong, tiny glass fibers and lock them into a really durable polymer resin. And what you get is this amazing material that's not only incredibly strong, but it's also way lighter than you'd think, and this is the key, it's practically immune to all the stuff that destroys old-school pipes. Let's see how that works in the real world.
All right, first up, let's talk about something we all rely on every single day: the water and sewer systems that are basically the lifeline of our cities. This is one of the biggest places GRP is making a massive difference. You know, for decades, our cities have been built on pipes made of iron and concrete, but they've got a real dark side. In sewers, there's this nasty gas, hydrogen sulfide, that literally becomes sulfuric acid and just eats the concrete from the inside. In our drinking water lines, the rough surfaces can become a breeding ground for bacteria. And eventually, they all leak. And the fix? Oh, it's a nightmare. We're talking torn up streets, huge bills, the whole mess. GRP, though, is a whole different ballgame. It's basically immune to that chemical rot that plagues older pipes. Its inside surface is super smooth, which stops all that gross biofilm from building up. And get this, that smoothness also means it takes less energy to pump water through it, which saves money. It's a direct answer to every one of those problems we just talked about.
And look, this isn't just about efficiency or saving a few bucks. This is about our health. Because they don't corrode or build up gunk on the inside, GRP pipes make sure the water that comes out of your tap is actually safe and clean. They meet these incredibly strict international standards for a reason. It's a quiet job, but a really important one.
But it's not just our cities. Okay, let's shift gears now. Let's talk about heavy industry, where conditions get pushed to the absolute limit. This is where GRP's toughness is really put to the test.
And this is where it really shows what it's made of. I mean, think about the kind of abuse we're talking about: moving harsh acids in a chemical plant, dealing with corrosive seawater on an offshore oil rig, or handling the massive pressure in a firefighting system. These are all places where metal pipes would just fail, and fast. But GRP? It just keeps on going. Let's zoom in on a perfect example: desalination plants, like that enormous one at Jebel Ali in the UAE. These places are incredibly tough environments, just constantly pumping this high-pressure, super salty water. For a normal steel pipe, that's like a death sentence. But for GRP, it's just another Tuesday. It performs day in and day out for decades. And the impact of that reliability? It's huge. Listen to this. We're talking about a 40% reduction in operational downtime. That means these massive industrial plants aren't constantly shutting down to fix broken pipes, which, as you can imagine, saves a staggering amount of time and money.
Okay, so we've seen how tough GRP is in our cities and in these crazy industrial settings. But you know, some of its smartest, most clever applications are in how it's helping us build a more efficient and, honestly, greener future.
For instance, in farming, GRP pipes don't corrode from fertilizers. That means less water gets wasted, irrigation is more efficient, and crop yields go up. Or in fish farming, that smooth, clean surface is perfect for keeping water quality high. But maybe the cleverest use of all is how it lets us fix the crumbling pipes we already have without making a huge mess. It's a technique called slip lining, and honestly, it's genius. Instead of digging up an entire city block to replace a failing old pipe, workers can just slide a brand new, slightly smaller GRP pipe right inside the old one. Then they fill the tiny gap between them, and bam! You've got a brand new pipe good for another 100 years, all without turning the city into a construction zone.
And the difference this makes is just wow. We're talking a 90% reduction in urban disruption. There was a project in Warsaw, Poland that did exactly this to fix their old sewer system. It was fast, it was efficient, and most importantly, it didn't tear the city apart. That's not just an improvement, that's a revolution in how we do infrastructure.
All right, we have covered a ton of ground here, from beneath our streets to the front lines of industry. So let's kind of pull it all together and just look at the hard numbers, the real advantages that GRP brings to the table.
Just look at how this all breaks down. You can trace the benefits.
See how that total corrosion resistance for cities leads to that 100-year lifespan? And that means 70% fewer replacements. In renewal projects, being lightweight is what leads to that incredible 90% drop in disruption, and it slashes project costs by 60%. And for those really tough marine jobs, that means 40% fewer repairs. You see the pattern here? No matter where you use it, the data just speaks for itself. GRP delivers massive improvements.
So, what's the bottom line here? It's pretty simple, really. We're not just talking about a different kind of pipe. Choosing GRP is a whole new way of thinking. It's about deciding to make a smart, long-term investment in our infrastructure, one that's built to last, designed for peak efficiency, and saves an incredible amount of money, time, and resources over its life.
So I'll leave you with this question. You know, most of us will never even see these pipes. They do their work completely out of sight, but they are the foundation of everything we do. And as we face the huge challenge of building a stronger, more sustainable world for the next century, it makes you wonder, could the answer to some of our biggest problems be this invisible material flowing unseen right beneath our feet?